Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. We're back with our series regarding hydrology education and going into hydrology specific topics. In this one we're going to talk about water supply systems and some of the things impacting that, what impacts the use of water amongst domestic users, and what is the strategies behind water supply in our current day and age. So first we're going to introduce the topic here. So water supply capable of supplying quantity of potable water is a necessity for any modern city. The elements that make up a modern water supply system include number 1, the sources of the supply, number 2, the storage facilities, and 3, the transmission to treatment facilities, 4, treatment facilities themselves, and 5, transmission from those treatment facilities to intermediate storage facilities, and then 6, the distribution facilities. In the development of public water supplies, the quantity and quality of the water are of paramount importance. And the relationship of these two factors to each of the functional elements is indicated in a table that I'm going to show here later. In systems where groundwater is the source of water supply, storage and transmission facilities usually are not required. In some instances, treatment facilities may not be necessary. So it's important to note when water goes through groundwater sources, there's a natural cleansing or natural filtration that takes place that allows that water to have some of the possible pollutants that is in the water taken out and removed. That's what our natural environment is able to do for us. And so when water never is able to go through groundwater sources and it just goes through impervious areas and then straight into a collection system, a lot of those pollutants are still left in the water. However, groundwater tends to be the best natural source of water treatment. So you can see this table here. We have the source of water supply to the storage, transmission, and treatment. And there's some intermediary play between some of these systems here. Then finally to the transmission and storage, and then finally distributed back to the system. So let's talk about water uses and quantities. Water use varies from city to city, depending on the climate, characteristics, and the environmental concern, population, industrialization, and many other factors. In a given city, water use also varies from season to season, day to day, and hour to hour. It's pretty obvious to note that there's probably going to be more water usage in the summer when it's more in demand and it's hotter than in the winter in most Western climates. In the planning of a water supply system, the potable water use and its variations must be estimated as accurately as possible. An average of about 322 billion gallons of fresh water was withdrawn daily from surface and underground sources in the United States. And that's actually a 16% decrease, I think, from the previous 5 to 10 years. Much of the water that is withdrawn is returned to surface streams in the form of wastewater or irrigation returns. Actual consumption of water by evapotranspiration or by incorporation in an industrial product is much less than the withdrawal. Municipal uses of water may be divided into various categories. Domestic use is that water used in private residences, apartment houses, etc. for drinking, bathing, lawn sprinkling, sanitary, and other purposes. Extensive lawns and gardens will result in greatly increased consumption during the dry periods. Commercial and industrial use is that water used by commercial establishments and industries. Specifically in the petrol and oil industry, it uses quite a bit of water to extract the oil from certain areas. Also think about that consumption during dry periods. Think about California, right? Especially for watering lawns to make them look green, it's going to require a lot of water during that period because there just isn't any rain or any reserves to draw from. In small residential communities, the commercial and industrial use may be as low as 10 gallons per capita per day, but in industrial cities, it may be as high as 100 gallons per capita per day. Public use includes the water required for parks, civic buildings, schools, hospitals, churches, and street washing. Water that leaks from the system, meter slippage, unauthorized connections, and all other unaccounted for water is classified as loss and waste. The loss and waste category is estimated at about 20 gallons per capita per day, but with proper construction and careful maintenance, it can be reduced to less than 5. So here's a municipal water table. Here's the use. The range is between 40 to 80. And this is going to be in gallons per capita per day. The commercial, industrial, public uses, the lost and waste, and then gives you the total, which can have quite a wide range. There's also a typical range seen in the far right at the table there. So we're looking at about 145 gallons per capita per day as the typical range. So let's talk about factors affecting water use. The average daily water use in cities in the United States varies between 40 and 500 gallons per person. Some of the many factors that influence withdrawals are discussed in this section. So first of all is climate. More water is used in warm, dry climates than in humid climates for bathing, lawn watering, air conditioning. In extremely cold climates, water may be wasted at faucets to prevent pipes from freezing. Population behavior. So water use is influenced by the economic status of the customers. The per capita use of water is much lower in poor areas than in wealthy areas. In unsewered areas, consumption may be as low as 10 gallons per capita per day. Then there's environmental concerns. Increased public concern about excessive use of resources has led to the development of devices that can be employed to reduce the quantity of water used in certain residences. And then industry and commerce. Manufacturing plants often require large amounts of water. The actual amount depends on the extent of the manufacturing and the type of industry. Typical water use values are reported in the table. Some industries develop their own water supply and place little or no demand on a municipal system. Zoning of the city affects the location of industries, so zoning information may be helpful. Then water rates and metering. If water costs are high, people may be more conservative in water use, and industries may develop their own supplies at a lower cost. Customers whose water supply is metered are more likely to repair leaks and use water with discretion. And then of course the size of the city. So per capita water use in sewered communities tends to be higher in larger cities than small towns. Typically the difference results from greater industrial use, more parks, greater commercial use, and perhaps more loss and waste in those large cities. So you can see these are the flow reduction devices. So think about the devices used on an everyday basis. Bathtub faucet, clothes washing machine, kitchen sink, shower head, lavatory faucet, and then the toilet. So the total is about 64 in gallons per capita per day. But these are reductions from the higher value of 30, 34, 27. So by using these flow reduction devices, you can bring down the total. You can see 242 divided by 64. That's almost 4 times as much. So you can make quite a big reduction on the amount of water being used just by using these flow reduction devices. Then we need to talk about the need for water conservation. In the Western United States and many other parts of the world, drought conditions have forced the residents of affected communities to reduce water use voluntarily. In some cases, the agency responsible for providing water has to ration the available supply. The most significant in such situations is that water use can be reduced between 10 and 40% without creating any serious problems for the residents. So we hope that lesson was helpful. We have a free hydrology terms guide that you can get in the description box down below for free. This gives you 3 pages of hydrology terms that are used in the industry or maybe for your exams. So go ahead and check that out. It's 100% free. We thank you so much for watching. And anyways, we will see you guys next time.